Today we'll be talking about efficient FastAPI testing with pytest, dependency injection, and snapshots. But before we jump into the topic itself, let me just quickly introduce myself. So yeah, my name is Jan. I'm staff software engineer and backend lead at Rand.co. I'm also author of several tutorials and courses at testdriven.io, and I'm CEO at Giacomelli, my own consulting company. You can find me on Twitter and LinkedIn if you want. And yeah, that's quickly about me. Let's start at the beginning. So let's play a little game called Have You Ever? So raise your hand if you have ever restarted CI/CD pipeline job to pass a flaky test. Have you ever had to update lots of tests, maybe even thousands, just because you've introduced a small change, adding a single attribute to a model, maybe? Have you ever hoped and prayed for the test in CI/CD to pipeline to finish much faster? Have you ever had a broken production and green pipeline in CI/CD? So, okay, I see we are all on the same page. Same problems all over the place. So I hope you'll learn something new today, how to avoid that situations. So let's start at the beginning. Why do we even do automated testing? What's the purpose of that? The first thing, at least for me, is to protect against regression. So once we have something built, we want it to work always, right? We don't want in 2 weeks for someone to introduce some change and then all of a sudden everything goes kaboom. We also want to have much faster feedback loop. It can be very cumbersome and time-consuming to spin up the application server, to spin up maybe even UI and whatnot, and try to really go through all the flows that should be covered to make sure that things are working. So with automated tests, we can tell computer, do that, try this scenario, this scenario, this scenario, and it does that because computers are very good at following the rules. If we say do that, they'll do exactly that. And we also use automated tests to verify our expectations so that our calculations are correct, that we are sending data to our analytics, that we are sending data to our CRMs and whatnot. But as we do that, we also encounter pretty common problems with automated tests. You've raised hands basically for any point that I asked. So yeah, that's because many times these tests take forever to run. When you have 10, 20, 30, 50, 100 tests, things seem to be great and they execute very fast. But if you have tens, thousands of tests, these things can become pretty slow, right? The next thing that's pretty common is that tests need to be updated every time that we change something inside the implementation. So these are tests that are not resistant to refactoring. For example, quite common cases in Python world when overusing monkey patching, and then all of a sudden you move module A to a place C instead of place B, and everything is red. And you need to go and update shitload of tests. The next problem that's quite common is also that tests are many times hard to read. I don't know about you, but I've encountered many tests that were like 3 screens long because there was this data and this data and that data and that data, and 70% of it was usually irrelevant for the test itself. And the last but not least, flaky tests. These are probably the worst because we can trust in our test suite. We can say, okay, if we have a green pipeline, things are working as expected, so let's just release to production. We are always a bit worried that maybe if everything is green, things might not be still as expected. But if pipeline is red, then we just go and try and restart and hope for the best. So let's talk about valuable tests that are not giving us the hard time and all these problems. So first thing, they protect us against regression. If we have tests that pass, but things are broken in production, that's not a good sign, and that's something we want to avoid, right? So we want to make sure that green test suite means things are working as expected. We haven't broken anything that was already there, so all good. The next thing is we want them to be fast. As I mentioned, if 10,000 tests need 30 minutes to execute, no one will ever execute them. Or they'll just sit and wait and hope for the best. They'll do context switching, because if you need to wait for 30 minutes for CI/CD pipeline to pass, then you just go and pick some other task. The next thing is we want these tests to be reliable, so not flaky. If we execute tests 1,000 times, we want to have 1,000 times the same result. The next thing is repeatable. So if I execute the test on my machine, I want to have the same result as if I execute it on CI/CD server or if you execute it on your machine. I want them to be resistant to refactoring. If behavior that was there before is still there and just the code structure has changed, I want the test to still pass. I don't want to update them every time there is a slight change in the implementation itself. If there are new things added, I want to add new tests. If existing things have changed because there is new requirement now, okay, I'll go and change that. But I certainly don't want to update something just because I'm using, I don't know, pydantic model instead of something else, instead of plain Python class. And another thing is I want tests to be readable. If you go and you see a failing test and you have no clue what the test is about, it's very hard to navigate and decide, okay, what's the problem now? Is this something that's flaky? Is this something that's failing for a reason? Is this something that's not even relevant anymore? So we want them to be readable, so when I see a test, I know what it is about and whether things are failing, why they are failing, and if they are succeeding, why they are succeeding. We also want tests to be resistant to unrelated changes. As I mentioned, if we have existing test set and we add additional attribute to a model, we don't want 10,000 tests or 1,000 tests to fail all of a sudden, because the tests were there before, the existing attributes were there before, so these tests that are there already are non-relevant for this change. So we want to avoid it. And we also want the test to be true, which means we want to make sure that we cover happy paths, we cover edge cases, invalid cases, and so on. For example, if we are validating email address, we want to test also with subdomains. We also test with special characters like apostrophes and stuff like that. We want to case for case insensitivity and so on and so on. So let's continue by taking a look into FastAPI application. That's a very simple one. I'll need to sit down so I'll be able to navigate the code a bit better. And we'll do two things. So we'll add a new required attribute to the model, and we'll remove existing attribute from the response, and we'll observe what happens. So that's a very simple to-do API built with FastAPI. So let's start at the model. Do you see it, or should I increase the font size? Okay. Just give me a second. No. Thank you. Yeah, that's the beauty of my laptop, which does not collaborate well when increasing this. Let me try to use the view. Yeah. There should be presentation note somewhere. Command Shift. No. Yeah.
Increase font size in all editors.
Yeah, sure. So
Fourth
from the last, increase font size for all editors. Okay, let me do that. So one more time. Okay, better now?
Yeah.
One more time. Okay, you should see it now, right? Okay, so that's a very simple to-do model. So we have ID, that's auto-incremented integer, title, description, and completed flag. Then we have API schemas, so one to create a new to-do item, one to update existing one, and then we have a read schema, which is used to return the to-do items from the API. Then we have a simple database setup with SQLite. Then we have CRUD functions to list to-dos, get one by ID, create a new one, update existing one, and delete existing one by ID. So nothing special. If you've ever used the official FastAPI tutorial, you should have seen something similar there as well. And then there is the API itself. So we don't deal with migrations. We just use the create all thingy from SQL Alchemy. Then there is getDB dependency function, and then we just use these CRUD functions to create our to-do items from the API schemas sent in requests. So we have create, read all, so which is a list, read by ID, update by ID, and delete. So nothing very special, one could say, but should be enough to prove the point. So let's now execute the test. So I just have a makefile because I don't feel like typing everything all the time. So this is the UTI is executing tests in here. UTE will be executing tests in here later on. So now we can see there are 5 tests. They all pass. OK, perfect. So let's take a look at these tests. So the first thing here is we have tests set up for SQL Alchemy. So we are using the in-memory one to make things a bit faster. And then we use dependency overrides provided by FastAPI, which allows us to override dependencies. And we replace the original getDB function, which is defined here, with this override getDB defined in the test, so that we are using the test setup for SQLite. Then we have auto-used fixture to set up database, to create and drop all tables. And then we have database session, which we use then inside a test to pre-fill the data. So here is a test to create to do. So we send some data, we assert status, we assert that the title is as expected. And since we are using auto-incremented IDs and we don't know in advance what the ID will be, we just assert that ID is inside the return data. So nothing very complicated. And something similar then for to do, but here we first pre-fill the database, so we add single row with a to-do item, and then we assert that the ID is the same one as we got from the database when adding it, and then we also assert that title is as expected. Something similar for update, so we pre-fill the database, we assert the status code, and then we assert that completed, which is by default false, as you can see here, is updated to the value of true. And then we have also the delete endpoint, so same story here. And then there is a list endpoint where we also pre-fill the database, and then we assert that we get a list. And here we got a bit creative, so we are using the read schema to make sure that all the returned objects have the schema shape as expected, and that's what we can see. So when we execute the test, they're all passing. Okay, so as I said earlier, let's now see what will happen if we add an attribute to the model itself. So here we have a priority. We just decided, okay, we want to have priorities for all the to-do items, and this is now a required attribute, so it should be provided when things are created, so we can't leave it to null. Let's execute the test now. Whew, everything is failing. So let's see. On create side, this is somehow expected because the priority is not provided, so let's fix that inside the main.py. So let's go here. We need to go to the create to do, and here we can say priority equals 1, because that's what we decide as the default one before we do any API changes. And if we run the tests again, the create one is not failing. Okay, so all good up to this point. But then we go to the get, update, delete, and list test. Here, we can see that getting the to-do hasn't changed even a single bit. We haven't changed the schema, so nothing about priority is relevant. What's the problem here? So we are pre-filling to-do items. And since we are not using priority here, the test is failing. So if we add priority, the test will pass. And if we do the same for update and for delete and for list as well, now we'll have a green test suit once again. But as I said earlier, right, so that's not something we want to deal with because that's a very small example. There are like 3 tests that I had to update for no good reason. But what if there would be 300 such tests? I could lose 2-3 hours for nothing, to gain virtually nothing. So we would want to avoid it. So that's the first thing. Let me roll all the changes back. We'll take a look at how to do that more efficiently a bit later. So now let's try to do the following thing. So let's say, okay, I accidentally deleted the description from the read schema because I was just clicking some buttons and it's not there anymore, and let's run the tests. They all pass. The test suit is green, although we've just introduced breaking change. If we would have iOS client depending on the API schema and reading the description filled out, everything would explode. And we would have a huge mess on production, which tends to be very, very keen to do that exactly on Friday evening. So that's certainly not a good thing. And why this happens? So as you can see here, I verified only that the ID is present and that the title is as expected. There is no verification about the description, right? So these tests are certainly not true. And since we don't know the ID in advance, it would be quite clunky to do anything like that, to make sure that we compare the full response, right? This would be better, but with many attributes could get very unreadable. But since we don't know this ID upfront, at least not reliably, we could say that it should be 1, but if we change the order of test execution, it might be 2, 3, 4. We can do that. Okay, so now let's take a look. What can we do to improve the situation? How can we do that a bit more efficiently? So the first thing that we can do is we can use factory fixtures. If you have used PyTest before, I'm sure you know fixtures, but taken from the PyTest official webpage. So in texting, fixture is provides defined, reliable, and consistent context for the tests. In other words, in PyTest, these are functions with PyTest fixture decorator, which are executed by the PyTest itself, and their result is then returned to the test using them. By default, the fixtures are static, right? So you can return some string, you can return some email, you can return to-do items. So one thing that we could improve in our existing example, we could replace the pre-filling of database with some fixture. But the problem there is that many times we need to just slightly alter small parts of data to cover all the cases, as we want our test to be true. And in such case, the static fixtures can be pretty painful to deal with, because then again, we might have 1,000 tests, 1,000 fixtures, and then again, if we need to add priority to every fixture, that's pain in the ass. Factory fixtures, on the other hand, are callable. So instead of returning the fixed result, we can return a function which takes keyword arguments and returns an object that we need with some sane defaults, and we provide just the overrides that we want to deal with. For example, if we want to have to do in completed state, then we would just provide completed. Everything else would depend on the sane defaults that are there to be used. This can improve the readability and also resistance to unrelated changes. The next thing that we can leverage are snapshots. So snapshots are captures of the output of tests at some certain point in time, and then we store them usually in text, bytes, images, so some external file format, and then we compare text execution now with the result that was captured when we were sure that things are working as expected. This is quite popular in UI testing for iOS, for example. In Python, I haven't seen that this much, but can be very useful when dealing with API tests. The great thing there is that we can automatically update the snapshots. For pytest, there is a plugin called Py, which provides CLI option to update all the mismatched snapshots. So for example, if we add a new attribute to the schema response, and that's something that we want to do, we'll see all the tests with the old snapshots will fail. We can check what the diff is, and if it's expected, then we just go, we add CLI option, we update the snapshots, we commit that to Git, and then from thereafter we'll have new snapshots, and every time the test result will be compared to the new ones. It also provides snapshot fixtures, so we don't need to deal with reading these files and loading them and whatnot. So there is just a snapshot fixture, and we can just assert, for example, response.json equals snapshot. We'll take a look at the actual usage slightly later. And the third, so the last but not least, is dependency injection. So dependency injection allows us to inject selected dependencies when object is created. So for example, instead of importing something, we can provide instance of use dependency, for example, a repository, which is responsible for data persistence stuff at runtime when some object depending on the repository is created, which makes it very powerful because it's very easy to swap different implementations. So for example, we can use much simpler and much more performant implementation for tests, and a real one, for example, that's actually using the database when the application server is running. If we can ensure that they're both having same interface and that they're both having the same behavior, at least during the test time, then we should be fine. And FastAPI, fortunately, comes with very easy to use and very powerful dependency injection framework. If you ever use Java, you probably know that there are very, very hard to use and messy dependency injection framework, but FastAPI one is really just like, yeah, use that function with type hint depends, and you can even use annotate to simplify things even further, and that's about it. So let's take a look, if we use these three things, how we can implement the same API with FastAPI, but make testing much more efficient. I hope that the font size is still the same as before. So as before, we have the same model. We replaced the auto-incremented integer with a string because SQLite does not have UID type, but we'll use UIDs. Then we have schemas as before, so nothing has changed there. So create, update, read one. Then we have the database setup as before, so this is still the same. And then we have dependency, which is now two functions. So instead of having the database session used directly, we use repository. And we also use UID provider, which is a very simple thing here. So it's just a wrapper around actual UID provided by standard library in Python. And there is this one, which is called fixed UID provider, to which we can provide some specific value, and every time that we call it, we'll get this same value, which can be very useful in tests to assert things with static values instead of having a new UID value, especially with snapshots, as I mentioned. This can come very handy. We'll take a look into this slightly later. So Then we have repository, as I mentioned here. So instead of using the database station directly in the API, we'll use repository. And it looks like that. So we have the abstract class which defines which methods should be implemented here. And then we have two implementation, the in-memory one and the SQLite one. The SQLite one is pretty much the same as the CRUD functions previously. And the in-memory one exposes exactly the same behavior as SQLite, but it just uses plain Python objects like dictionaries and so on to store these values. Obviously, if we would use in-memory implementation on an application server, every time that they would restart a server, we would lose all the data. So certainly not suitable to deploy with that one. But during test time, which is quite limited, and we are always creating new database and then we are dropping all the data out, we can achieve exactly the same behavior. That's easier said than done, so we want to test that. And we can test that with contract test. So we can define set of tests that needs to pass for all the implementations. So here is the first one, where we say, okay, if we add to the repository, we need to be able to get it back by ID. So the thing here needs to be exactly the same when we fetch it from database, and we want to be able to also list the to-dos once they are added. And we also want to make sure that once the to-do is deleted, and the exception is raised because it's not there anymore. Once we have such contract, we can then use the test classes to just implement the fixture, which is here not implemented, so it will just raise an error. And here we just create a new instance of the in-memory one. And for the SQLite, we obviously need also the SQLite database connection and so on. We need to create tables and we want to drop them. So we add this part and then we return the instance of SQLite repository. So a bit of an overhead, but this can simplify things inside the API testing later. So let's go further. Let's take a look at the tests now. So now we have, as you can see, create, and snapshot fixtures used. So let's go to the conf test to see what's happening there. So these are now factory fixtures, as mentioned before. So instead of returning just a static value, we return a function, which is returned here. And by default, we set some same defaults, but we can always provide keyword arguments to override them as appropriate. And here, for example, in the repository test, we can just use the same defaults. Nothing is really relevant. So we just want to make sure whatever is added can be fetched back. So we don't provide any overrides, but if they're relevant, we can do that. And then we have a similar thing to creating the repository, so we can provide to-do items via keyword arguments, and we can use them to pre-fill the repository. And then there is the create API client factory fixture, to which we can provide the dependencies that we want to override, and they are overridden for the test time, and then they are cleared at the end. So let's go back here. So now here we can see we are using the fixed UID provider, so there is some fixed UID value. And now anytime that this one will be called, we'll just return this value here. And we also override the to-do repository to make sure that we are getting the in-memory one instead of the SQLite one, which is returned by default by this dependency function. And then something similar for reading all to-dos. We improve the test here by adding 2 to-dos instead of only 1. And similar for read, similar for update and delete as well. So here, as I mentioned earlier, we can just say that the response JSON equals the snapshot, and we can take a look at the snapshot. This is how it looks like for the test create to do. That's what we expect to be returned. And then for the read, read all, read, update, and so on. For the delete one, there is no snapshot because we just assert that there is status no content. So let's run the test now. Okay, now we have 9 tests, which is more than before, but they're all passing. And if we now go and do the same thing, so let's add priority to the to-do model. I also need to import integer. What happens now? So now only 2 tests out of 9 are failing, and these are the repository tests. We can go, we see, okay, so it's a not null constraint on the priority. We go here, we see, we are using the factory fixture for creating to-do. Where is the contest? So it's here. We can just say, okay, let's add some same default for that. And there we go. We are back at the green test suite by just adding a single line. So now if we have 1,000 tests using this factory feature for creating to-do, we still need to update 1 line to make it sure that all of them are passing. If there are new tests that are relevant for the priority itself, then we can add them and we can alter the priority there as expected. But for the existing tests, priority is not relevant, so we can just make sure that they are still passing. And then if we go and we do something stupid again, so I delete the description because I was sloppy, and we run the things again, we can see that now all the API tests that are using the read schema are failing because there is a diff in snapshot. We can check here. Minus means that this thing is missing. So description is missing here, and it's missing here. That's not what was intended. Oh, look, here the description is missing. I can just return it, and if I run the tests again, they're green. And if I would need to now add some new attribute because some requirements just came in, I can do this. I can add it, and then I'll see that the tests are failing. But now I check and I see, oh, yeah, that's the new attribute. I'm fine with it, so I want to update that in all the snapshots because it's safe. I can then use the CLI option provided by FastAPI, so poetry run pytest snapshot update. So that's the CLI flag, so snapshot update. I can run it now, and then I can happily run the tests as so far. So as you can see, it's very easy to update the snapshots when changes are intended, and they also caught the issues that were introduced by some unintentional changes. Last but not least, let's compare the efficient and non-efficient tests. So I already mentioned, so here we have 9 instead of 5 tests, but if we compare the execution times, we can see that despite using the in-memory SQLite, these tests take roughly 12 times more to execute, right? Yeah, okay, now I have, let me update the snapshots again. So you can see, right, so it's 0.4 instead of 0.35, right? So it's a significant difference. Here, that won't impact anything, right? Both executions are instant, but if you multiply that by 1,000 or 10,000, the difference can be significant. So the efficient tests also prevented the regression. As we were able to see, the efficient tests were resistant to unrelated changes, right? So we were able to very easily make them pass by adding a single line to the factory fixture. And we also made sure that tests are more readable because we don't deal with all the database crap and whatnot. Obviously, with the least test, things are a bit longer than before because we've added 2 to-dos instead of 1, and we also wanted them to be different in title, description, and completed flag. But we could also just use the same defaults and still make sure that to a return and so on. So, yeah, that's about it. Maybe just one thing to conclude before we jump up to questions. So I presented a couple of methods and approaches that you can use. Don't take them as silver bullet. If you have 100 tests for a very simple API that just wraps some ML model and have some settings there and so on, you might not get all the benefits or they will be neglectable. So no need to just go home and just take a stab at everything and update it to these patterns. And if you want to apply these things to your existing projects, never go and throw everything around and start updating everything. Take a small feature that comes your way and maybe do some experiments there to see how things work in your context, with your use cases, with your requirements, with your knowledge, and so on. And then once you can confirm, okay, this is what I need, this will improve my situation, then you can go and slowly update the things to be done that way. But don't just go and jump straight on your head because you'll just lose your teeth. That's it, so time for questions.
Oh, thank you very much. So we have quite a few questions. First one, how do you manage properly the independence of the tests? For example, we created a to-do model in our DB for one test. How do you make sure the model does not interfere with other tests?
So usually it's the easiest if you ensure that things with fixtures. So if you do anything, always clear the things up. That's why you have the yield option in fixtures, so you can do some things before the tests are executed. You can yield your data persistence, whatever it is, and then after the yield you can do the cleanup and make sure that there is nothing left, so the next test is always running inside the clean things as expected.
Next one, how do you type hint factory fixtures, especially the ones using keyword arguments?
So for the keyword arguments, to be honest, I never type them because that's just the investment I'm not willing to put in. Yeah, I mean, it's a test code, so if something is off, so be it. But I do always type the output, so you can use callable and then whatever, and then the return types. And then here inside the function that's returning, you just define the type as you would use with the regular feature. And that's it. I wouldn't go down the rabbit hole of type hinting the keyword arguments, because already in the production code, this can be a significant pain in the ass.
Okay,
that's it.
Next one. When should we use dependency injection overrides for test versus unit test mock patch functionalities?
So I usually try to avoid the mocking if possible. It's not possible all the time. For example, if you are using some integrations to third-party systems like CRM, what I like to do there is to create a wrapper around the CRM integration, even if there is some SDK for, I don't know, for Mixpanel or HubSpot or stuff like that, which has a very simple interface which can be used from any code that has some business logic. And then I use create autospec to create object with exactly the same interface as the original one, and then I mock from there. Because if you use magic mock, it's very easy to end up with tests that are passing, but the things have changed since then, and then it's pain in the ass. But with everything else, if you can gain a control by injecting something, especially the code that you wrote, I wouldn't go and inject SDK for Mixpanel, which is some third-party library, because this can be a nightmare. But the code that you wrote, if you inject it, because that gives you more control during testing, and you just need some factory function which ties together all these different objects into a usable object for running the application on application server, then I would do that. So yeah, don't mock if you're not forced to. And when you are using mocks, try to mock your code, not someone else's code, because it's a nightmare when there are breaking changes. Just had to deal with something on with breaking changes in Stripe SDK. And yeah, I lost quite some blood and sweat.
Okay, thank you. Luca asks, I understand what you are doing with factory fixtures, but I'm unclear about what is happening with snapshots and dependency injection. How do factory fixtures, snapshots, and dependency injection interoperate?
Okay, so let's maybe go to one of the tests. So factory fixture, let's go maybe to the this one, the read one. So the factory fixture for creating to-do is used to create an object as we would like it to have, and we provide some overrides here. By providing the ID value, we make sure that the snapshot will be happy because it's always the same ID whenever we run the test. Then we use factory fixture for creating repository to pre-fill these to-dos to repository, and then once we have the repository in the desired state, then we provide it to the dependency overrides, which then goes to regular FastAPI dependency injection. So by doing that, we say, okay, instead of using whatever this function is returning, which is defined here, instead of that, return the function, which is in this case lambda, because we don't need anything else, that's returning this repository which we put into the desired state. Okay, so when you call the API by using the test client, when FastAPI here in the main.py here, when it calls this get-to-do repository by its dependency injection framework, it won't return the SQLite one, which is defined here, but it will return this one that's defined inside this lambda function. So this is how these things interoperate and make sure that you have the full control all the time, so you can set the values that are ever changing, for example, the UID to some fixed value to make sure that snapshot is happy. And if you don't have snapshot, the test will fail, and with update snapshot CLI flag, you can make sure to create the first one. And then you get something like that inside the snapshot file. SyropY will read that, and then here it will compare whether the JSON returned in the API response matches the JSON specified in the snapshot file. Hopefully that explains it a bit better.
Okay, thank you. We still have time, so a couple of questions left. What is your general takeover on VCR, especially when the API returns a huge page load?
VCR, what's the VCR?
You know, when you run a test that has pytest VCR as a declarator, you can say there's a YAML what the API has returned, like the HTTP request. Yeah, you save the HTTP request as a YAML file.
Yeah.
And then when you rerun the test, instead of doing another HTTP request to the API, maybe it's flaky or whatever, it basically gives you the same payload.
Okay, yeah, so that's something similar as a response library for mocking the requests, where you can also specify, yeah, I mean, if you need to actually test the part that interacts with the third-party API, yeah, go on and use these libraries. They can be super handy. But nowadays, I usually, if they are very easy to use and it's easy to verify them by running just all the methods that are on the integration itself, by having some script, I do that. And then if the frequency of changes with the integrations is very low, so this is updated, and when there are breaking changes in the API, I just don't mind adding additional tests there, because everything is pushed into some corner, and if there are no updates, then who cares?
And yes, VCR is fully automatic, so it updates the integrations for you, the mocks, and it creates the mocks for you automatically.
Yeah, sure. So if you need it, go on and use it.
Okay, we are.
But I've never used it myself, so hard to actually compare it to anything that I was just saying.
Okay, we are over with time. Thank you very much, Jan.